Great. Well, yeah, once again, hope you all enjoyed that session. I can see Dan, our next speaker, is already in the lobby. So Dan, I'm just going to send you a quick invite, and then we should be good to get going. Perfect. Hey Dan, how are you doing?
Good. How are you?
Yeah, very well, thank you. I mean, I can see you and I can hear you all clearly, so I don't know if you'd like to share your slides, but to everybody, hope you've enjoyed the session so far. I'm really excited to have Dan from Tableland here for another workshop. So Dan, feel free to take it away.
Awesome. Sounds good. So I'll start, with a few slides. You can see this, correct, my deck?
Yes, all good.
Okay, cool. Yeah, so we'll go through a few slides and then dive into a workshop. And the workshop, basically what we're going to build is like in the theme of open data, like a paid inbox type of application where you have smart contracts controlling how people DM each other, where all of like the user data and all the DM data is publicly open, accessible within Tableland. But in order to like DM someone, you have to pay a certain amount of ether. So it's gated, basically like open data with gated contract rights within like the Tableland database. So maybe let's like start with what Tableland is. We can dive into that and preface with some of the prizes that we have. So $2,500 total. And basically focuses on just like using what we call controllers and associating those with tables to enable like an open data economy sort of. So it'll allow, like a good example is just allowing like have a database, a table within Tableland storing a bunch of data, and then using controllers to provision how people can insert into that. But those controller rules are all baked into smart contracts. So anything that you can write in a smart contract can control how people can update a specific data set. So quick high level on Tableland. So we're a decentralized database network. You can sort of think of it like a cloud or serverless type setup, but it's all Web3 native. So you can store really anything. It could be open data sets. It could be something from a data pipeline. It could be just simple application data, which is kind of what we're doing in this workshop. And then also just note, like if you are using like large pieces of data or have like large pieces of data that are really destined for networks like IPFS or Filecoin, Tableland definitely helps augment that process because you can really like store a lot of information that describes those CIDs as an example, or deal data all within tables, and the data can be written within smart contract calls. So pretty flexible in terms of how you can use the protocol. Quick high level on, okay, like why would you use Tableland? So there's different ways you can store data. You can store that on chain in a smart contract, but there's drawbacks there with purely storing just data within contract storage due to things like cost or mutability, or even just query features. There's just lack of ability to query information. And that's why networks like Tableland exist, or even like the graph, which is just full on indexing for everything. So on-chain has some drawbacks, but it's decentralized in nature. It has identity and access, or like consensus mechanisms to make sure that everything is verified and only the right people are interacting with specific tables. So we'll get into that in a little bit more detail. But other options that people store Web3 data could be just like decentralized storage. But if you're storing like, let's say a static or like a JSON file that's tracking maybe user data or like DM data or any sort of information like that, if that data needs to mutate, it brings up some challenges because then you introduce some off-chain processing that you have to do, and you have to like sort of like sync a smart contract with this off-chain interaction. So with Tableland, you can actually like have on-chain driven actions that mutate data within this Tableland network that sits off-chain. And again, that could include something like a CID. If you have a large piece of data, Tableland has a limit on 1 kilobyte per cell. So that helps give you a good reference point for like how much information you can store within a table. And then lastly, like another way that people often store data is just a typical database where there's obviously drawbacks there if you're very Web3 native and trying to like build applications with that approach. But also just like from a functionality standpoint, it limits, especially in our setup, this like open data setup. If you have like a centralized database, how do you provision access to some party that you don't know about that you want to contribute to a data set? So obvious drawbacks there, but they come with like people use databases, hosted setups because they're efficient, they have great tooling, they've been around for a while. So it's just like there's different pieces that from all these three approaches that are beneficial, but I think there are drawbacks with all of them. And that's really where Tableland comes in with more of like a hybrid approach, where we combine some of the best pieces of all three of those sorts of setups into the Tableland network. And like quick high level on how it works. So like to envision exactly that like end-to-end interaction, let's say you have like an application, Tableland is like you can create and insert data into tables using smart contracts. We also have an SDK and CLI, so you can, like, depending on your ideal development environment, we're pretty flexible in terms of the tooling that we have there to interact with the protocol. But once let's say you have a front end app, the theme of the workshop, it's like anyone can sign up or anyone can try to DM someone on the platform. That will go through some interaction. Table creates and writes are always going to start with a blockchain like driven approach. So think of it as like a data stream coming from the blockchain that interacts with what we call the Tableland registry smart contract. That registry accepts SQL strings. So you can say, hey, create this table, hey, insert this data into the table. Then the Tableland network is basically watching that registry contract for events that are emitted. So it's cheaper than contract storage because we're just using like call data to emit those SQL events. And then each node in the Tableland network materializes that SQL, assuming all that the access controls and the data is valid. So it's that two-step approach. You interact with the smart contract that is materialized in Tableland, and then when you read data, at least in the current state, everything just goes through like a gateway call to the Tableland network. So you can do things like make a read query to query across all of your tables, really like any table in the network. So that's like in a more broad picture, you can have composable applications across like different apps. It doesn't have to be something that you own in terms of like the table itself and the data itself. Like you can create these tables or these data sets, but anyone can potentially read that data. So it's not only just like collaboration from a write perspective if you want to design your application that way, but also enabling that data to be openly accessible and usable for others. And then just a little bit more context on what that process looks like. If you dive into our docs, there's a lot of details on the like fundamental concepts and just how everything works. But again, there's like this base layer, smart contract deployed on different chains. We support Ethereum, Polygon, Optimism, Arbitrum, and Filecoin. So you can deploy smart contracts, you can create tables on any of those networks. And then when you go through the process of like creating a controller that can make sure that only the right people are mutating data, and then again, all that is accessible via like a read query at a gateway that we host. Just a little bit more context there. So the two different, probably like the two most popular ways to set things up. And the tooling that we'll use in the workshop, we'll primarily focus on like blockchain driven or like SQL with smart contracts, but thereafter I'll post like a repo of all of like the finished code and what it looks like when we actually add a front end and all of this. We'll be focusing just on that smart contract side today, but when we look at the end-to-end stack, it'll incorporate some things using the SDK as well. And last thing, if you are looking to like brainstorm for ideas on how you can use the protocol, as noted, it's like pretty flexible how you can store data. Like you can really, like any use case needs a database. So it could be anything from like open public data sets to identity control. On top of that data set itself, the application data DAOs are another great use case because that's like a native, like that's really a core principle of a data DAO is being able to have like this open access with different parties involved to contributing to that data set. And then on the other side of things, like if you are using NFTs in any way within your stack, having like mutable metadata is beneficial. Gaming is also relevant there. But let's dive into the workshop. So basic setup, we're gonna start by, there's a number of templates that we have on the Tableland network GitHub repo. So we'll start with one of those templates and then basically create 2 smart contracts. We'll have one that we'll just call like example, and that'll be the contract that controls the table creation and all the rights and interactions, setting the controller with those specific tables. And then we'll also have like a controller contract that gates the like this inbox table that we'll take to allow anyone to like, basically insert data into that table. And then after this workshop, I'll post like the full code, and that'll have like a front end that shows you exactly how all this data flows together and like what happens when someone logs on. They try to like create and insert tables, but we'll just show some logging through hard hat and ethers to give you an idea of what it can bring you. So I'll pause there. I don't know if there's any questions like in the chat, but I want to give that opportunity first.
Yes, I can shout one out to you from Matthias, who asks if you could explain the differences between Tableland and building an indexer.
Mm-hmm. Yeah, so like an indexer, like you're gonna have some like hosted database setup that is like reading all these events. Like so you could set up like a custom indexer that could even just like watch the Tableland smart contract for all like the different SQL events. But I think like the benefit here is that we're taking more of like a serverless approach. So if you want to like set up an indexer, that's totally fine. But that means you have to set up all that infra. You got to pay for that infra. And with us, it's kind of just, you can create tables without really thinking about it. As long as you know how to develop with a smart contract or like use JavaScript, then once you deploy tables, and like the smart contract is a good example because it really is like this like machine that once you deploy the contract, now you can interact with it and you never have to set up database infra on your own. It just sort of works. So I think that's like one of the main advantages there.
Amazing, thank you. And we've had a message in the chat saying they can't wait for the demo, so perhaps we should jump into that.
Yeah, for sure. And and if you have any questions, like hop in our Discord. We're at Tableland on Twitter. I'm at DT Buchholz if you have any like specific questions. And then DocSite is where a lot of this information exists. But cool. So let's maybe go back 1 second. So yeah, if we start off, so Tableland Network is the handle on GitHub. You can see all our repos, and if you come in here and search for a template, there are some different options. We'll be using the hard hat TypeScript template. So if we go here, you can copy the URL and then clone that repo to get things started. And one of the useful tools that we have is a tool called local Tableland. So that allows you to spin up a hard hat node locally, as well as a local Tableland node. And those basically like work in sync. We deploy this like registry smart contract on the hard hat node for you, and then we spin up this Tableland validator that watches that hard hat node for the contract, and then like all interactions thereafter will do that. So basically, like once you use local Tableland, you don't really have to think about the setup or anything. You can do local first development, which just makes things a whole lot easier in general. So yeah, clone the repo. If you haven't installed local Tableland, check that out as well. It's in the docs. And yeah, so let's dive into what we have built so far. So I've gone ahead and just like set up basically like the framework for this contract already, and we can talk through all the code. But some dependencies, you should install OpenZeppelin and at Tableland/EVM. So OpenZeppelin will be helpful for, especially with like inserting data into Tableland. Every time like you interact and insert data, what's really happening is like we're taking a string and sending that to the Tableland registry smart contract that emits the string that subsequently emits the string. So you'll have to like work with concatenation and converting, let's say, integer or unsigned integers or hex addresses to strings, and then like building a SQL string with that information. And that's where the strings library is pretty helpful. And then the ownable contract we're using here is just to gate some of the methods within our contract to make sure only the owner of the contract can actually successfully call that method. ERC 721 receiver. So every table in Tableland is an ERC 721 token. In order for a contract to own the table, which is what we're doing here, it has to implement this receiver method, which is down at the bottom. And if you don't have this, basically there'll be an error that occurs when you try to like mint a table because the contract can't own that type of token. And then the last couple of helpers that we'll import. So we got Tableland deployments. You'll see this throughout, and it's just like an easy way to not really think about, not have to think about, okay, like what is the contract that I'm interacting with? So it returns like an interface to the Tableland registry contract and then allows you to make method calls that are native on that contract. And then the last one is SQL helpers, which is a helper library for SQL. And that like basically formats the strings for you. So it just makes it easier to like insert, update, delete, and like format that SQL appropriately. Okay, so now up at the top, what we have defined are like static values that store table information. So if we look at like a table identifier, like when we create this users table as an example, what will happen is it'll create a string that looks like this. So it's a globally unique table identifier across any chain. Since we're developing locally in this example, you'll see like user is a custom prefix that you set. And then after that, there's a couple underscores. And in between those underscores, you'll have a chain ID. So if you're doing local development with that local Tableland setup, the hard at node chain ID will be 31337. If you're using Ethereum, this should be a chain ID 1, Filecoin chain ID 314, etc. And then the last piece of information is the unique table ID. So every table on a specific chain will have its own table ID. And these are auto-generated values. And then the first just prefix part is what you're setting up on your own. So we'll store this information up top. We're gonna have a two-table setup, a users table and an inbox table. And there are more from like an application perspective, like better ways to design this. We're keeping things simple to start, but you could imagine like an inbox table. You could definitely have a single table of all of the messages ever sent across all users, but that would get pretty large pretty quickly. So like an ideal setup would probably have like an inbox table per user and have just more of a better design there. But again, keep things simple in this setup with a single table that contains all messages that will be sent between users. Next part, we have our constructor. So within the constructor, there are two things that are occurring, and it's really just creating the tables. So we'll have the users and inbox table values updated up at the top, and then we're using that Tableland deployments method to create a table, and then we associate that table with a specific schema. So our users table will have a unique identifier for every user. We'll have the address of that user, and then we'll also have like a custom name that the user can set for their profile. And then the inbox table, similar type of method, at least like the setup, but the data itself will have a unique identifier for every message sent within the inbox. Will have the address of the sender, so who is like trying to send a message to the receiver. So we'll also store the receiver's address. And then lastly, we'll have the message itself, which, as I noted, cells, like if you're storing data in Tableland cells, 1 kilobyte limit. So keep that in mind if you want anything larger than that. Or if you had like a more complex setup where you can send like pictures, that's where you would like interact with probably IPFS or something similar in that realm. So cool. We deploy the contract. What happens? We have two tables created. So now we can interact with those tables thereafter. So the next method does exactly that. And this is in like the theme of open data. This method isn't gated by anything. So when you try to insert into the table, anyone can actually do that. There's no like access control on it. It's entirely open. And we'll show that in the controller, like how we enabled that setup. But if you did want to like gate things, you could, maybe throw an only owner modifier on there, or use the like Tableland controller to provision that. Or even just like to clarify, when you create a table, by default, the only one can insert or mutate that table at all is the owner of the table. So if you were to deploy things, not worry about our Tableland controller setup, the only one that could do an insert is, in this case, address this, because it's the contract that actually owns the table. But anyway, so we'll allow anyone to insert into this users table. It includes some of that information around, okay, what is the table that we're inserting into? What is that prefix value? The SQL helpers helps like make things a little bit easier to work with. And within this method, you'll notice we specify the columns that we're inserting into. So remember that users table has like a unique ID column. It has an address and a name. If you don't specify the ID column, by default, if you have like ID integer primary key, it'll auto increment. So it just makes it easier to like insert data with unique row IDs there. And then this last piece is the actual data that we're inserting. So you can see we use SQL helpers .quote. Since both of these in Tableland are text values, any sort of string has to be enclosed with single quotes in SQL. So we'll wrap the data in quotes, and then we'll basically say, okay, I'm some random user. I want to sign up for this platform. So when I want to do that, I'll make this method call. It's going to be abstracted at like the application layer, but I'll make a method call, I'll set my custom name. It inserts the address of the message sender here. So then you have like that unique identifier for the actual hex address, and then the custom just like string that they want to set their value to. So we insert into the users table. Okay, cool. Now we have a user. The next thing we'll do is insert into the actual inbox table. And this is where the Tableland controller comes into play. So with the inbox table, we'll have a receiver and a message. So I want to send a message to address ABC, and I want to say hello or something. You'll notice right here we have this payable modifier, function modifier, and that'll be important when we dive into the controller. But same type of setup. It's like, hey, I want to insert data into this table. The only difference here with the previous example is that, yes, we're going to make sure that inserts are actually gated by a particular rule. And then we insert into the table the sender's address, receiver's address, and then just that message using the SQL helpers. And always note, like the one thing that always gets me is just like these commas between the different values. Just don't forget that, because it'll affect like, okay, the material, the actual creation of the table within the Tableland network. Okay, so quick recap. Once we deploy this contract, we'll create a users and inbox table. We have a method for inserting into the users table. Anyone can do that. Nothing like funky around that. It's like open access. And then we'll also insert into the inbox table, which is gated by a payment mechanism. And note that another popular way to gate information is just like, maybe it's NFT ownership or something similar like that. So anything you can write in a smart contract can gate how someone mutates that data, or if they even can. The last method we have is just setting the access controller for that inbox table. And it's pretty simple. It's, okay, who is the table owner? So you call the set controller method. First, you specify who the table owner is. You specify what the table ID is, and then what the address of that controller is. Great. Now let's dive into the controller. So a couple similar helpers that we have here from OpenZeppelin. And then from the Tableland, there are a few new ones down at the bottom that we didn't have in the last contract. So there's a Tableland controller, a Tableland policy, and then policies, which is a library to help with some of the information related to those other two contracts. So when we create this controller contract, we're going to call it the inbox controller. It inherits from these two, but the core feature here is a get policy method. And when you set a controller via this set controller method, now every time anyone tries to interact and like mutate data on that table, instead of having like the default only the owner can mutate data, now it'll always point to this controller contract address and say, okay, what is the policy for the person trying to call this? So say, hey, here's the caller. And then we can establish, at the end, you'll see this like Tableland, or even up here, the Tableland policy is returned that defines the rules for inserting that data. So in this example, we're saying maybe the owner has like admin control over anything. So they can insert, update, delete data within the inbox table. They have like full permissions. You don't have to do this, but I just wanted to show what that would look like. And that's where like the owner method, the ownable method comes into play. So only the owner of whoever deployed this controller contract can mutate data. But then like the thing that like really makes this whole setup work is just this simple line here, where we say, okay, if the caller is not the owner of the contract, we're going to gate the policy in a specific way. And we're going to require that the message value of any like interaction when you try to call insert into inbox table, it's going to be gated by something like this. So the message value has to be half an ether, or probably a smaller value would be nicer to set up. But you could have like tiered approaches, different DM options. And then once it's all said and done, you return the policy to make sure that that person can actually deploy information or send information via the DM. And then last piece, I won't go through this just because we're running out of time here, but the deploy, if you dive into the repo, you'll have like the deploy scripts all set up, and we'll deploy the example contract, we'll deploy the inbox controller, set that inbox controller, and then go through some steps for adding yourself to the users table. So now there's that record. And then the last thing we'll do is make a couple of attempts to send DMs. The first one will fail because remember we had like a 0.5 ETH gated write, so it won't work properly. But then maybe if you 0.6 or something like that, if you try to send with enough, if you send with sufficient amount of ether, then the DM will go through, and then at the UI layer, everything will populate properly. So minute left. I'll pause there and see if there's any final questions.
Yeah, sure. So I think we had a couple over who can read the data, but obviously you answered that with the different gates. But we've also had one as to whether you can explain the overhead costs related to using Tableland.
Yeah, so if we go into the docs page, there's a cost estimator that just shows like, okay, how does Tableland compare to on each chain, like how do writes and table creates compare to just, or just like more of a reference, not a comparison to existing solutions. So overhead there is like you're paying for gas fees on creates and writes. Like that's the main thing to keep in mind. But then right now the network is we're in sort of like an open beta. We're going to launch like our own mainnet in about a year from now, but we're live on mainnet chains, so you can use it on mainnet chains. So like the value there right now is like an early adopter. You don't have to really pay for anything. It's all free. The only thing that you do have to do is you just pay for gas costs, and we're not involved in that at all. It's just like any sort of chain operation there.
Amazing. And then if you are happy to, one more final one potentially from Slavic, who asks simply, how large can the table be? Is there a maximum number of rows?
We have, like in theory, there's not really a limit, but like right now since we're in this open beta, we cap the number of rows at 500,000, but that's more of like an arbitrary number. In the future, we foresee that not really being an issue. And if you ever like run into that row limit, we can probably make changes for our like open beta network. So in theory, no limit, but right now 500,000.
Amazing, really cool. Practically limitless then. But no, thank you very much for your run through and workshop there. I'm sure it is extremely useful for all of the participants. And of course, if you could share any docs or resources which you think the hackers might find useful, that would be really great too. And we can add those to the recording. But unless you have any final remarks, I'd just like to say thank you once again.
Awesome. Yeah. Appreciate it. Thanks for having me.
Perfect. And we'll see you on the Discord server. Cheers. Bye-bye.
Later.